Okay. Now, I haven't gone through this yet, so I've literally just read that thing once. So, we'll see how we go with this. The actual thing will be in your section here in the questions for teaching. Anyway, so multiply through by the square of the denominator, collect all terms on one side. Yeah, okay, and then factor to determine the factor cubic. Interesting. Okay. So we're going to sketch the cubic by examining the signs. Yeah, okay. Okay, so we're starting off. Yay, my pen works. That's really exciting. I've got 8 over 2x minus 3 is less than or equal to 2x minus 1. So I'm going to square both sides by the denominator of this thing here. So timesing both sides by that squared, which is going to give me 8 2x minus 3 on the left side, less than or equal to 2x minus 1, 2x minus 3 squared on the right side. What was I going to say? Oh yeah, so the reason we're timesing both sides by the square is because otherwise, if I'm not timesing it by the square, then I could be timesing it by a negative number, like the result under here could be a negative number, and therefore I wouldn't know what would happen with this inequality. Whereas if we're timesing by something squared, then it's always going to be a positive number. Okay, so I'm going to move this to the right side. And I'm going to swap these around just because I'm pedantic and I want my squared thing first. Doesn't really matter, but anyway. So I've got 0 less than or equal to, I won't, oh yeah, so 2x minus 1, and then 2x minus 3 squared minus 8 outside of 2x minus 3. So I've moved my 8 over to the 8 thingy-jiggy, 8 outside of 2x minus 3 over to the right side, and thus it's subtracted now because I've subtracted it from both sides. So there's been no multiplications, so my inequality is still the same. Now I'm going, so 0 is less than or equal to, and now I am going to start factorizing it. So the common factor here is obviously the 2x minus 3 in both of these cases. So I'm going to say 2x minus 3. And then the first term is a bit of a doozy because it's 2x minus 3 outside of 2x minus 1. So I'm going to have to expand that, and that's fine. And then minus 8 on the end, because 8 times 2x minus 3 gives me negative 8x minus 3. Okay, so I'll expand that now. This stays the same, so it's 2x minus 3. And then on the right side here, I'm going to have to expand this, which is going to be 4x squared minus 2x, that one there, minus 6x, yep, so minus 2x, is it? Yeah, and then minus 6x, and then plus 3 minus 8. Cool, less than or equal to 0, 0. 2x minus 3, 4x squared, that's going to be minus 8x, and that's going to be minus 5. Cool, can I factorize that? Hopefully. I can't pull a 4 out because of that. I'm going to use the Psf method, so my product for this part here. And you haven't been introduced to Psf method, but you can solve it any other way as well. Psf is just a really good, I think it's better than the cross method, but you can use the cross method. All I'm going to do is put the product of this and this, including the negatives, obviously. So 4 times negative 5 gives me negative 20. Sum is negative 8. So two numbers that multiply to give negative 20 and add to give negative 8. Well, it can't be negative 1 and 20. It can't be negative 2. Oh, it could be negative 10 and positive 2. So negative 10 and positive 2 would add to give me negative 8, multiply to give me negative 20. So I'm going to go with that. So positive 2, negative 10. And then this 4 has to come down and divide underneath. This is part of the Psf method. The reality is you could solve this using the quadratic formula as well. And I'll do it with the quadratic formula as well, just so we're all hunky-dory. So this is over 4, and this is over 4, and that's going to simplify to positive 1 over 2, and that's going to simplify to negative 5 over 2. So then my factor there ends up being 2x, this thing goes here, plus 1, and 2x minus 5. So I can take a 2 out of everything altogether. Okay, so I'm just going to, oops, I don't think that's okay. Yeah, I'm just going to move that over there. Oh, I missed that bracket. That's, oops, okay. That's fine, put that bracket there. And so that means I can factorize this now into 2x minus 3, and then this part here factorizes into this. So I can put that as 2x plus 1. I'm pretty sure that works out, isn't it? Like 2 is 10, plus 2 would be 8, and that gives us negative 5. Yeah, good. Okay. 2x plus 1, 2x minus 5. I can't really factorize a 2 out actually, because I've got this number here and this number here. That would make that unfortunate. So that's fine. That is the factored form. Now this PSF might have confused you, so I'll just quickly go through factorizing using the quadratic formula, or completing the square. Either way, I'll do quadratic formula. I don't want to make this too long, but it's probably going to be a little longer than going through all the methods. So quadratic formula, we've got A equals 4, B equals negative 8, and C equals negative 5. And remember, it all has to eventually tie into A outside of X minus, is it alpha, whatever it is. Yeah, let's call it alpha, and X minus beta. And those alpha and beta are the two solutions to the thing that we end up getting. So we've got, as in the two solutions that we end up getting down here, where X equals blah, 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 blah. So we've got negative B, which is going to be 8, plus or minus the square root of B squared, which is 64, minus 4 times A, which is 4, times C, which is negative 5. Over 2A, which is 8. Great, so 8 over 8, that's good. That's going to be nice and simple. This part in here, let's just quickly work that out. 4 4s are 16 times 5. Who knows? Let's bring up the calculator. 5 times 16, 80. Ooh. Oh, but that's negative 80, so that's fine. So it ends up being 64 because I've got the negative 5 and the minus here. So that's all good. Bring that back up. So 64 plus 80 gives me 144. How convenient. And then the square root of 144 is obviously 12. So I've got 8 plus or minus 12 over 8, which is going to equal 8 plus 12, which is 20 over 8, or 8 minus 12, which is negative 4 over 8. Okay, so 20 over 8 is 10 over 4, which is 5 over 2. 5 over 2, great. And negative 4 over 8 is negative 1 over 2, of course. These numbers should look somewhat familiar. Remember what we ended up with here, positive half and that thing there. Cool. Obviously opposites, but that's fine because we have to plug them in. So plugging these values, because these are what our x's equal, these values into alpha and beta here, then I'm going to get A outside of X minus 5 on 2, and then X minus negative 1/2, which is the same as X plus 1/2, so plus 1 on 2. And my alpha is what? Well, alpha was 4 back over here. Sorry, A, not alpha, my mistake, sorry. A is 4. So 4 outside of X minus 5 on 2, X plus 1 on 2. So let's multiply that 4 in, kind of split it into 2 times 2, and multiply 2 into each one of these, and I can do that. So I'm going to multiply 2 into the first one, I'm going to get 2x minus 5, and 2 into the next one, I'd get 2x plus 1. And Oh, does that look familiar? Yes, it does. It's what I ended up with back here. And now you can see why this Psf method is actually really great for just quickly doing something that takes a little bit longer over here. But obviously still only works when our roots or our zeros are rational numbers. Yeah, they don't have to be integers, but they do need to be rational. Okay, sorry. So that was a side note. That was, oops, don't want to do that. That was just, oh, come on. Just select everything. There we go. Move that over there as well. In fact, actually, let's just, okay. I will put a little circle around it. And it's just side note 2. And this is this part here, side note 1. And that was just us working out our factor. So now we've got this. So my zeros essentially are at x equals, well, for the first one, x has to equal what needs to be positive 3. So 3 over 2. 3 over 2, because 2 times 3 over 2 would give me 3, and then that goes to nothing. Good. Here it's going to need to be a negative a half. Negative a half. And lastly, this one would have to be a positive 5 on 2. So there's my zeros. Great. So I've got, yeah, let's kind of plot that. Ultimately as well, I've got a quadratic. Let's not forget that, because I've got 4x cubed. Well, I've got, x times x times x. So there's, x cubed there. So I know I'm going to start off and it's positive. All of the x's are positive. That's positive, that's positive, that's positive, positive, positive. Means I'm going to start down here and I'm going to finish up here. So that's good to know. My x is sort of negative a half. So let's say that's negative a half. And then positive 1.5. Cool, we'll go there. And then positive 2.5, as in 1.5 being 3 over 2 and 2.5 being 5 over 2. Now remember, I need to start off here, I need to end up here, and these are all linear zeros. Sorry, is it linear zeros? They're all zeros of degree 1, so meaning that it is going to pass through the x-axis of each one of these. Not that that's specifically important, because remember, this is just a tool for doing our solution. So starting here, I go over here, I go down here, and then I go up here again. Great. And all of these equations, all of these zeros, essentially my function needs to be greater than or equal to 0. So I'm essentially after these sections, all of those parts. So what's that? Well, the first part is a collection. So that's going to be, and this is negative a half, and this one is 3 over 2, and this one is 5 over 2. So the negative a half, clearly negative a half is less than x. Now it could be less than or equal to. I need to look at my original function. Okay, so just briefly looking at my original function here, there is one value that's not going to be equal, and that is this one here, which is the positive 3 over 2, because that would result in a discontinuity, so it can't be equal to that. So let's keep that in mind. Can't be equal to that part, but it can be equal to negative a half. That works. And then less than 3 over 2. So it's all of these values except for the actual 3 over 2, because if I plug in x equals 3 over 2, I get 0 on the bottom, and then I get 8 divided by 0, which is undefined. So that's part, and then I got to do this part here, and clearly x is simply greater than 5 over 2. And that should be my solution, unless I've stuffed something up phenomenally, which hopefully I haven't, because 14-minute video. No, that should be fine. Yeah, let me know how you go with that. Okay, I'll pause it and stop it there, and I'll track this on YouTube.